All right, so we're going to finish 2-6. We have 2 theorems at least today. These need to go on flashcards. So here's the first one, and I can guarantee you these are going to show up as a question on your test or a question in a proof often. So here we go, theorem 2-2. And never memorize proofs by their theorem number. You need to know what they say. And I don't expect you to regurgitate exactly what they say, but you have to be able to paraphrase it and get that general thought across. So this one is your congruent supplements theorem. If 2 angles are supplements of the same angle or of congruent angles, then the 2 angles are congruent. Sounds like a bunch of gobbledygook, doesn't it? Right? So look at the picture that's down below. And it says if angle 1 and 3 are supplements, so let's call this angle 1, and we'll call this angle 3, and we'll call this angle 2. So if angle 1 and angle 3 are supplements, what do you know about that? They what? They add up to 180 degrees, right? So if they're supplements, and I don't know what they are, but I do know that whatever their angle measures are, that they would add up to 180 degrees. And then if angle 2 and angle 3 are supplements, I also know that they add up to 180 degrees. So what this theorem is saying is then angle 1 and angle 2 must be congruent. So let's just put some numbers to this. What would you like to make this angle? Degree-wise.
136.
Do we have to do that? I don't want to do that math. How about 130? I'll go with that. It's much easier to do the math. 136. It's too early for that. If that's 130 and these 2 are supplementary, what's angle 3? 50 degrees, right? So all this is saying is if angle 1 and angle 3 are supplements, and angle 2 and angle 3 are angle 2 and angle 3 are supplements. Now you know what this is, right? So this would be 130 degrees also. Then they're saying that that must mean that angle 1 and angle 2 must be equal to each other. If these 2 are supplements and those 2 are supplements, doesn't it stand to reason that the 2 angles that are supplementary with the same angle must be congruent to each other? And there's your picture. Right? Alright, so look at number 18. If the measured angle D is 135 and the measured angle G is 45, and F and G are supplements, the measured angle F is. So if I were you, I'd be drawing this out. I don't do well with just words, and most of you don't either. Measured angle D, and we don't know that they're connected, so I wouldn't necessarily connect them, but I would definitely draw out a picture. 135 degrees, and this is angle D. And then angle G is 45. Just put that right here. G is 45 degrees. And then we have a new one here, F. F and G are supplements. So F and G are supplements. When I draw F, I want to draw it like this. How did I know to draw F as an obtuse angle? Yeah, if F and G are supplementary and G is 145 degrees, then I know that this one's going to have to be obtuse because what's 180 minus 45 degrees? Isn't that 135? So then the measured angle F is 135 degrees. It's the same measure as angle D because angle D and angle F are both supplementary to the same angle G. So if they're both supplementary to that same angle G, they both must be equal. And that's what we're concluding there. You're going to forget about that. So keep practicing it. So do this one here on your own. If angle A and B are supplements, and the measured angle C is 85, the measured angle B is 95, then the measured angle A is. I want you to figure that one out. Drawing a picture might be helpful. you to share your answer with those around you. What did you come up with? So here's a picture that I happen to draw. It's not necessarily fully accurate, but angle A and B are supplements, so I drew a linear pair. And then the measure of angle C is 85 degrees, and the measure of angle B is 95 degrees. So A and B are supplementary. C is 85. They didn't exactly say that C was supplementary to something else, did they? No. So you kind of really need to draw your picture to figure this one out. Well, you should have. And so from here, I can figure out what A is, just because 180 minus 95 must be 85 degrees. Did I even need to know that C was 85 degrees to do this problem? No. So in this particular problem, it really didn't apply to this theorem up here. It applied more to the fact that A and B are supplementary. So you are right. A was 85 degrees. Paragraph proof. I'm not a big fan of paragraph proofs, although you will use a paragraph format as you get into higher level math to justify certain things. So let's just go ahead and look at this. All you do with a paragraph proof is take your two-column proof and take your statements and your reasons and write them as if-then form. If this, then that. If this, then that. And then you can clean up your grammar by taking away some of the if and thens and just writing them as statements so you don't have so many ifs and thens. I can guarantee you that I will not trust you on a paragraph proof. Why? It would be a nightmare for me to grade, let's just be honest. It would just be a nightmare for me to grade. It would take me forever. So I can guarantee you that's not going to happen. So let's go through here and see. So we have given that angle 1 and 3 are vertical angles. So they have to even tell us that based on picture. Now, and what did I do? What can I conclude from the fact that 1 and 3 are vertical angles? What did I just do in the picture? They're congruent. So your conclusion from here to here, and this is part of your pre-proof planning, is that angle 1 is congruent to angle 3. So directly following that given statement, typically, I'll say something to the fact that they're congruent. Well, this particular one you may not, because we're trying to prove that angle 1 and angle 3 are congruent. So we're actually proving the vertical angles theorem. So I can't actually use the vertical angles theorem in the vertical angles theorem proof. Remember I talked about that the other day? So since I'm trying to prove that if they are vertical angles, then they are congruent, that's what I'm trying to prove, I can't use that within my proof, so I have to get around it. So look at what they do. Angle 1 and angle 3 are blank angles because it's given. So is it supplementary or vertical? Vertical. So I like to write the word vertical. Then they go from the given statement to here. Angle 1, and look at the picture. Angle 1 and angle 2 are blank angles because they form a linear pair. So it have to be supplementary. So I know that those are supplementary. Then angle 2 and angle 3 are blank angles because they form a linear pair. Is that the same as the sentence above? Yeah. So don't we say supplementary again? So aren't they using the congruent supplements theorem above to prove the vertical angles theorem? So they've said that angle 1 and 2 are supplementary, angle 2 and 3 are supplementary. Isn't angle 1 and angle 3 supplementary to the same angle? So what can you conclude about angle 2? I'm sorry, what can you conclude about angle 1 and 3? If 1 and 2 are supplementary, 2 and 3 are supplementary, and you've got 1 and 3 are supplementary to the same angle, what do you conclude about 1 and 3? By the way. Two angles that are supplementary to the same angle are congruent, right? Well, they didn't use that here. It would have made a much shorter proof. So instead they went ahead and did, okay, the measure of angle 1 plus the measure of angle 2 is 180. They went from number 20 to number 22. They talked about the angles being supplementary, and then they talked about the measures of those angles adding up to 180 degrees. If two angles are supplementary, don't they add up to 180 degrees? Isn't that the definition of supplementary angles? So that's what they're using here, because the sum of the measures of, again, that word supplementary, angles is 180. Don't they do the same thing again here? So 21 and 23 correlate to each other. So these two correlate. These two correlate. And so that's going to say the same thing. Then by the blank property of equality, the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. Well, where did they come up with that? Look in the proof above here to see where you see the measure of angle 1 plus the measure of angle 2. What number is that? 22, right? And then they said the measure of angle 2 plus the measure of angle 3. Where do you see that? So where are they going to use the reflexive or the transitive property here? Yeah, the reflexive means that it does what? This would have to look like what? They'd have to be mirror images, right? I personally disagree that it's the transitive, because look what they did. If this is equal to 180, and this is equal to 180, they're saying that these two are equal. Does that follow the transitive property pattern? No, because it should have been this equals this. What you end up with here should have started with here. So it should have had 180 equals that. So there's a lot of people that would disagree with you that's the transitive property. What did I tell you? If it looks like the transitive property but they don't follow the pattern, what does it do? What do they do to get that? If both of them equal 180, didn't they set them equal to each other? Isn't that substitution? Didn't I just substitute in, if this equals 180, I can substitute this in for that. Isn't that what they just did? True or false? Yeah. So I actually disagree. That's substitution. So substitution. Property of equality. Then, what do they do from here to here? How did the left side change from measure of angle 1 plus measure of angle 2 to just the measure of angle 1? They subtracted the measure of angle 2 off, didn't they? So this disappeared. So isn't that your subtraction property? Property of equality. Then the last one, notice that there's a notation change. Didn't we have that a lot yesterday in a couple of our proofs? Okay? So angles with the same blank are congruent. So the measure of angle 1 is congruent to the measure of angle 3. Angles with the same properties or angles with the same measure? Measure. So don't just run through your proofs, actually study them as you're going through them, because at some point you're going to have to do it on your own. You're not going to be given little choices. On your test, you have a proof where you have all of the statements and you have to come up with the reasons, and it's actually multiple choice. But you have to choose. It's hard because you have to choose the correct order of those statements and which ones match up to which one. So you got to be able to know what your properties and theorems are. Make sure you're studying them before Friday. All right, this one, the congruent complements theorem is exactly the same as the congruent supplements theorem, only it deals with complements. So this one, if two angles are complements of the same angle, or congruent angles, then the two angles are congruent. So it's the same theory as before. If I have one angle, let's just say I have angle A and angle B, and then there's little old angle C sitting out here alone. And I don't know, angle A is 50 degrees, and angle B is 40 degrees. If angle A and angle B are complementary to each other, and I tell you that angle C is complementary to angle A, what do you know the measure of angle C is? C is complementary. Angle C is complementary to angle A. C is complementary to A. So then angle C is congruent to which one? Angle B. If you think about it, if C is complementary to A, then that means that C is 40 degrees. So that must mean that angle A or angle B and angle C are congruent. So you're going to have to use some of that sets of problems to solve it. So 27, angle A is a supplement of a 165-degree angle. So draw a picture of that. So might it look like that? Angle A would have to be acute, right? Everybody should be writing. Angle B is a complement of a 75-degree angle. So here is a 75-degree angle, and then here would be angle B. That could be a picture of that one. Circle the relationship between A and B. Well, first of all, what's the degree measure of A? A is supplementary to this angle, right? B is complementary to this angle. Does it follow the congruence complement theorem? Do you have two angles that are complementary to the same angle? Yes or no? No. Not at all. But what's 180 minus 165? So 15 degrees. What is 90 minus 75? 15 degrees. So how are you going to answer that question? They're congruent. So they're throwing a question in here that has nothing to do with the complements theorem. You've got to love that. All right, last page. Here's two more theorems. We've got 4 all together today. Theorem 2-4, all right angles are congruent. You're like, well, that's a no duh. Of course they are. Well, you're going to use that in a proof. So put on a flashcard, run it. If two angles are right, would be on the front, then they are congruent would be on the back. And you might want to also put in small words, all right angles are congruent, somewhere on the front or the back of that card. You need to be able to use that forwards and backwards. I don't know how backwards would work. The compass wouldn't work on that one. Theorem 2-5. If two angles are congruent and supplementary, then each is a right angle. Does that make sense? If they're congruent and supplementary. So if they're supplementary, that means that they must add up to 180 degrees. The only way for them to be congruent is if they are both 90 degrees. If angle R, number 28, if angle R and angle S are right angles, then finish up the statement. What is congruent to what? Angle R is congruent to angle S. 29, if angle H is congruent to angle J, and angle H and J are supplements, so they're congruent and they're supplementary, then what do you conclude about the measure of angle H? Equals the measure of what? Measure of angle H equals what? The measure of angle J, which equals what? 90 degrees. So number 30, cross out the theorem you cannot use to find an angle measure. Can I use the congruence complement theorem to find an angle measure? I tell you that two angles are complementary to the same angle. and I don't give you any of the angle measurements, then the only thing you can conclude is that the two angles that are complementary to the same angle are congruent. So you may not be able to find the angle measure with that one unless I give you the supplementary angles measure, or the complementary angles measure. Then you could. Same thing with the supplementary angle theorem, and what about the vertical angle theorem? So depending upon what they give you, you could actually use all of them to find an angle measure, but it depends on what they give you. On all of these, I can determine congruent angles. But if I give you one of the vertical angles here, like for instance, right here, if I give you that 40 degrees and that 50 degrees, can you find the measure, and that's 90 degrees because of the marker there. Can I find the measure of angle 1? How? Brody, what? It's 90 degrees. Why? Because it's vertical, this one. So then we use the vertical angle theorem to find an angle measure. All right, what about angle 2? You could use vertical angle theorem, right, to say that it's 50. Could you have also found the degree of this angle here, those two together, which would be what, 130 degrees? And could you have used that here? Well, that's your definition of a linear pair, right? Because they're supplementary. So that's not exactly the supplements theorem. But if two angles are supplementary to the same angle, so isn't 50 degrees supplementary to this angle? And isn't 2 supplementary to this angle? So looking at it that way, I could use the supplementary angle theorem to the congruent supplements angle theorem to find that measure. So I could, and I could do the same thing with the complements. So what's 3? It's 40 also. I find it much easier to use your vertical angles there. A lot quicker. But there's none of those that I would cross out. Alright, so we found all those angles. We're not going to do the lesson check. Alright, so let's go ahead and do a proof. So take out your paper. I'm going to write down the following. So given angle 1 and angle 3 are vertical angles, and you have a picture that looks like this. And your proof is to prove that you are to prove that angle 1 is congruent to angle 3. Now obviously you're like going, okay, that's a theorem. Well, you're not allowed to use a theorem. We're going to prove the vertical angles theorem, which was our paragraph proof that we just did. But this picture is slightly different, and the proof is slightly different. I just want to prove to you that you get to certain things in different ways. So this can be similar to your paragraph proof. So statements and reasons. So I'm going to give you your statements. What should be the first statement? Yep. So angle 1 and angle 3 are vertical angles. Statement 2, angle 1 and angle 2 are supplementary. And angle 2 and angle 3 are supplementary. This should start to look familiar, yes? So I'm going to leave the last statements, because I think at this point you can start to figure out what you should be doing just based upon what we've done today. So when you get to that point, stop. This is a typical proof progression. Ready? What is your reason for the first statement given? 100% of the time. Then for statement 2, how did we go from the given and or the picture and say that angle 1 and angle 2 are supplementary, angle 2 and angle 3 are supplementary? How do I know that angle 1 and angle 2 are supplementary? You can't just say linear pair though. What are we going to say about linear pair? Angles that form a linear pair, so use your, or if two angles are a linear pair, you can use your if then logic here. So if two angles are a linear pair, then what? Then they are supplementary. And you don't have to justify how you know that they're a linear pair. You've got a picture up there which you can look at. But you can't say given here because there's nothing in the picture or here that said that they were a linear pair or that they were supplementary. All right, so then from the fact that the angles are supplementary, how do we conclude that their measures add up to 180 degrees? What are you going to say there? So we're going to use that if-then form again. If two angles are supplementary, then they add to 180 degrees. Notice that the progression went from the fact that you had essentially a linear pair in the picture. From that linear pair in the picture, you said that they were supplementary. Then from the supplementary, you could say that they're 180 degrees. You can't jump from the picture to the fact that they add up to 180 degrees. You cannot skip that step there. It's very picky. You're in a geometric chord law, don't forget. Lay out all the foundation. So then from here to here to number 4, what am I going to do? We're trying to get to proving that angle 1 is congruent to angle 3. Don't I have I have the measure of angle 1 here and the measure of angle 3 there. I need to get them together in one equation. So how can I go from 3 to perhaps an equation in number 4? You've answered every one of them so far. Mr. Carmen. Keep the measurement in there though, because that's part of this one. So because they're both equal to 180, can't I then set them equal to each other? So the measure of angle 1 plus the measure of angle 2 is exactly equal to the measure of angle 2 plus the measure of angle 3. How do we know that we can do that? What says that? I went, notice that from here to here, the left side is the same, but the right side, 180, changed to this. Why? There you go. We took this amount right here and we plugged it in or substituted in for the 180 because it also equals 180. So the reason from here to here is substitution, property of equality. keeping in mind always, I'm trying to get to this proof statement of just the angle 1 is congruent to angle 3. What do you think we can do from here to here? I'm trying to get just angle 1 and angle 3 in the equation along, that's it. Subtract the measure of angle 2 from both sides, right? So if I take that off of both sides, I have the measure of angle 1 is equal to the measure of angle 3. And all I did was essentially take off those from both sides. And what says that I can take away something from both sides? Everybody see is that subtracting the property of equality? Then I'm kind of telling you there's only one more statement left. How are these are very similar to each other, aren't they? Aren't they just a change in notation? Can I just write a change in notation? Change the equal to congruence? What says I can do that? Because I can go backwards and forwards on this depending upon what the proof statement says. So again, go back to what that paragraph proof said. If the measures of two angles are equal, then those angles are congruent. So I'm using measure here. So if the measures of two angles are equal, I'm using the word equal because they're using the equal sign here. Then I get to my second statement. Then the angles are, change in notation, congruent. So this is about the third or fourth time we've had a change in notation. So you need to start to realize how that progression occurs. You can chunk these progressions together in your brain and just start studying them. If you need to put some of those progressions on a flashcard because you start to see them happening over and over again. For instance, one of your progressions that you might want to put on a flashcard would be linear pair goes to what? If you have a linear pair, what do you conclude from there? Supplementary angles. What do you conclude from there? If you have angles are supplementary, what do you conclude? They add to 180 degrees. So there's a block right there that we've already seen. So I put that progression on flashcards so you start to learn it. And that becomes a tool that you have in your brain.